All right, here we go. We have reached the end of the semester. We are going to do the final exam review. We're going to start off with Unit 1 because that would make the most sense. All right. The very first thing we kind of talked about was SOHCAHTOA, even pretty much geometry, right? We've done all of this in geometry. So if we look at this first one, the first thing I'm going to do is I'm just going to get this beta value here. All right. We know in a triangle, right, all angles have to add up to 180. So if you want to think about it, we already have 90 degrees. So 35 plus beta needs to be 90. All right. So that is just going to be a 55 because 55 plus 35 gets us that 90 degrees there. All right. Now the next ones are going to require a little bit of trig. So if we want to think about if I'm going to solve for B first, all right, I'm going to use this 35-degree angle. All right, if you look at the two that I highlighted, we have the adjacent and we have the opposite. All right, it's the opposite corner or the opposite side from that 35 degrees. So what goes with the opposite and the adjacent? This is where our SOHCAHTOA thing, SOHCAHTOA. All right, SOHCAHTOA, this is where that comes from. Which two go with the opposite and the adjacent? Well, that is your tangent function. So we are going to say the tangent of that angle of 35 degrees is equal to the opposite, which is 12, over the adjacent, which in this case is b. That's our variable. Do a little bit of algebra here, and we are going to find that b equals 12 divided by the tangent of 35. All right, so we're just going to type that into our calculator. Really this whole class, we are pretty reliant on our calculators and our unit circles. So, all right, I'm just going to type that in. 12 divided by the tangent of 35. They want nearest hundredths, so 2 decimals, so that's 17.14. So B is 17.14. Right? And then the next one, if we looked for C, I'm going to stick with the opposite. And then this one over here is our hypotenuse. All right. And I'm sticking with the opposite. I don't want to use my B value because maybe I made a mistake on B. I'm going to use the numbers that they give us, and that's just going to be like just an extra layer of security or caution, I guess, using the numbers that they give us. That's just going to make life, a little bit easier. So we have the opposite and the hypotenuse. That goes with the sine. So the sine of 35 degrees now is equal to the opposite over the hypotenuse, which in this case is C. So just like last time, we're going to say C. I'll do it over here. I ran out of room. C is 12 divided by the sine of 35. All right, so again, let's throw that into the calculator. 12 divided by the sine of 35. What is that? 20.92. So there we have it. There's a couple different ways we could have found beta, but what we have is fine. I'm sure it'll come up on the next one here. Let's see here. We have a 15-foot ladder leaning against the side of our house. So here, I'm going to draw my house. There's my house. All right. We have a 15-foot ladder. So my ladder is orange. We know this thing is 15 feet long. If the base of the ladder is 5 feet away from the house, all right, so here, this is the grass, that is 5 feet away. All right. I'm going to assume it makes a 90-degree angle. What do we have to do? Well, probably part A and B here. What is the angle of elevation created? Now, the angle of elevation is going to be this one down here. Think about if I was, right here, if I'm standing on the ground or lying on the ground, I have to look up, all right, to the top of my house. How far do I have to look up to the top of my house? That is what the angle of elevation is. How far back do I have to kind of tilt my head to see that? What is the angle of elevation? Well, let's think about which parts of the triangle we have. We have the adjacent, and we have the hypotenuse. All right, which to go with the adjacent hypotenuse, your SOHCAHTOA, that is your cosine. So the cosine of theta, that angle that we are looking for, is equal to the adjacent over the hypotenuse. Now that's 5/15. If you want to reduce that fraction, you can, totally. Right? You don't need to, but you can. All right, so how do we solve for the angle? Well, we have to inverse both sides of this equation here. Right, so I'm just going to do something like this. So we know theta, right? These two things cancel each other out. Inverses always cancel out. So we are left with theta equals the inverse cosine of 5/15. Again, if you wanted to call that 1/3, you can. Right? You're just reducing that fraction down. And from here, punch it into your calculator. We don't want to do the cosine. Remember, we are doing the inverse cosine. So press the second button, your cosine, and then type in that fraction. So we have 5/15, or 5 divided by 15, gives us 70 point, what do they want? All answers should be around the nearest hundredth. All right, so 2 decimals, what do we have? 53, 70.53. All right. How high up does the side of the house does the ladder reach? So we are looking for this piece right here. There's 2 ways we could have done this one. We could do the Pythagorean theorem. We could say x squared plus 5 squared equals 15 squared. All right, throw that into our calculator. We're going to get x equals something. I'm going to take a shortcut. 15 squared minus 5 squared. And then we have to square root that answer, the square root of 200. I don't know what that is. 14.14. All right, so that would have worked. All right, that is the answer. Another way we could have done this is using trig. Now, it doesn't matter which one we use. We could have said the tangent. Actually, here, let me keep everything color-coded. The tangent of that theta that we have. So that's 70.53. Right, equals x over 5. And so we would have had x equals the tangent of 70.53 times 5. Throw that in your calculator instead. Let's see what that gives us. It's going to be, slightly off because we did round, keep in mind. But it should still be really close to that 14.14. All right, so we're off by 1/1000. So that's pretty close. All right, so that's just another way you could have done it. And we could have done it a third way using the 15 instead. We would have used the sine. We would have said the sine of 70.53 equals x over 15. And again, that would give us that same answer here, right? So just to prove my point here, the sine of 70.53 times the hypotenuse on that triangle, which was 15, right? It's going to give us that same value. All right, so that's how we do that one. Now we're using special right triangles. So before we do the special right triangles, I'm going to draw a picture here. Our special right triangles, we had 2 of them. We had a 30, 60, 90 right triangle. All right, so the shortest side is always across from the smallest angle. I'm going to put an X there. All right, so that is the smallest side. Now, the longest side of any triangle is always across from the biggest angle. In this case, it's our hypotenuse. That's across from the 90 degree. It's always twice the shortest side. All right, so if you want to go from the shortest side to the hypotenuse, all you do is double it. You're just going to straight up times it by 2. All right, now the bottom one, kind of the middle piece here, the longest leg of the triangle, or the longer leg of the triangle, you need to multiply by the square root of 3. All right, if you want to go backwards, maybe say you are given the hypotenuse and you want to get back to the shortest side, you divide by 2. All right, if you're given the longer leg and you want to get back to the shorter leg, you divide by the square root of 3. And then you're going to have to rationalize it. All right, so we're probably going to have a problem like that when we go back to the next page. All right, so that's our 30, 60, 90 triangle. The next one is a 45, 45, 90 triangle. And again, these are things that we first talked about in geometry. This is an isosceles triangle. Two congruent angles means two congruent sides. All right, so the legs on this thing are congruent. I'm going to call these Y. Just use a different letter here. So these are congruent. So if the left leg is 3, then the bottom leg is also 3. Now, to go from the leg to the hypotenuse, you multiply it by the square root of 2. All right, so these are just some things that we're going to have to kind of remember here. And if you wanted to go backwards, you would divide by the square root of 2 and then simplify or rationalize that denominator. All right, so these are things that you should probably commit to memory. You don't remember them, you're going to have to do the Pythagorean theorem or a little bit of trig. These are just purely shortcuts, and we use these a lot to kind of really make the unit circle, which is probably what we're going to talk about in chapter 2. All right. So on this next one here, you special our triangles to find the exact values here. So they're given a 60-degree angle, so I'm going to throw a 30-degree right here, right? 30, 60, 90 triangle. So we have to think, which side do they give us? Well, the one across from the 30 is always the shortest side. All right, so to get the hypotenuse, all right, double it. That's just going to be a times 2. All right, so y in this case is 16. To figure out the one across from the 60, that's the one you multiply by the square root of 3. So x is just 8 square root of 3. All right. Now this next one, 45, 45, 90 triangle. So we automatically know x and y are congruent. So whatever we get for x, we're going to get the same thing for y. But notice on this one, they give us the hypotenuse, right? We need to go back to the leg. The hypotenuse is always longer. So one way to think about it is, do you need to multiply? Do you need to divide it? We'll just kind of think about it. Should my answer be bigger or smaller than the one they have? So in this case, x needs to be smaller than 10. So we need to divide this guy by the square root of 2. So when we do that, we're going to have x equals 10 divided by the square root of 2. Right? Now on that last page, I said we're going to have to rationalize it. What does that mean? We don't like having radicals in the bottom. So to fix that, we need to multiply the top and the bottom of this fraction by the square root of 2. Because when we do that, we have 10 radical 2 on top, all divided by the square root of 4, right? Square root of 2 times square root of 2 is square root of 4. However, we know what the square root of 4 is. Square root of 4 is just a normal 2, all right? Now, if we look at this fraction here, what can you do with the 10 and the 2? You can simplify it. That is a fraction you can reduce. So this turns into 5 times the square root of 2. So we know the answer for x and for y is 5 square root of 2. And again, we know that because these two things are congruent. So let's see here. Before I commit to doing the second page, let's just see how long it is. All right. I'm going to end it there. This one might take a minute. So there you go. Page 1 of the review. We'll see you guys in the next one.